So I got a question from a student a couple days ago, actually. I'm just not getting to it, for help in this homework problem, which is complicated, right? So let's just dive into it. Find the change in enthalpy, and let me get my marker here. Find the change in enthalpy for freezing this amount of water. Let me make some notes over here. Over here to blue and say my mass is equal to 20 kilograms, which is equal to 20 times 10 to the 3 grams, right, of supercooled water at 20 degrees Celsius. So temperature is equal to minus 20 degrees Celsius, which is equal to plus 273, 253.15 kelvins, right? And pressure is equal to 1 atmosphere. Okay. Now, this is water, so the first thing I'm going to do is I'm going to go ahead and find the moles of this, because I admit I sneak ahead and I see moles right here. You see that? So let's find the moles, and we're going to do the molecular weight of this to get the moles. I'm going to look this up in a periodic table and find out it's 18.02 grams per mole, right? And I go from grams and grams per mole to moles, which is going to be about 11.0, no. What is that? I can't do that in my head. Let's do this. It is 20,000, right, divided by 18.02. And that gives us 1110. So 1109.9. 1109.9 moles, right? And all I've done is just read this. I read that, 20 kilograms. I read that. I read that. Okay. Now, so what I'm asking, now what I've got to do is I've got to find out what's the freezing of that. So there's a nice hint here in this question, and that is I'm given some molar heat capacities, and I'm given this. This is kind of a nice hint. Think about the steps involved. Okay, so the first thing I'm going to do is I'm going to think about the steps involved. I'm going to say, all right, so in step 1, I've got water at minus 20 degrees Celsius, right? And at step 2, I've got, okay, so what we can think about this as water going from water at minus 20 to water at 0, right? Because it's a state function. Enthalpy is a state function. So water, in other words, we can take this up to water at 0, and then we can take it to solid at 0, right? And then we can take it back down to solid at minus 20, right? And so that's and I have those hints because these things are given to me, right? These molar heat capacities are given to me. I'm not given the heat of fusion here in this question, so I have to look that up. All right, so first of all, I'm going to think about this step. Liquid water to liquid, liquid at minus 20 to liquid at 0. And that is going to be Q is equal to MC delta T, right? And the mass, except, my C is given to me in moles. So I'm going to do NC delta T, because the heat capacity was given to me in moles. You see that, reciprocal moles. So I'm going to say NC delta T, which is equal to 1110 moles, right? Times, and this is liquid, right? So liquid water to be 76.1 joules per Kelvin mole, right? Times change in temperature, which is 20 kelvins. All right, which is, just a minute here, let me get my calculator out. It's 110 times 76.1, was it? 76.1 times 20, which is equal to 1689. Now 1.69 times 10 to the 6. 1.69 times 10 to the 6 joules. 1.69 times 10 to the 6 joules, right? And this I'm putting heat into it. Find the change in enthalpy. So I'm putting heat into it. So this is going to be endothermic. Got to think about that for a second. Is that right? I'll come back to that in a minute, okay? So, but anyways, it's going in one direction. Now in step 2, which I'll change my marker here, change my color. Step 2 is from liquid to solid at 0 degrees Celsius, right? So this is just the heat of fusion is equal to the molar heat of fusion times the heat of fusion, and I'll have to look that up. And I know I've got 110 moles, right? And since I'm freezing it, I'm getting heat out of it, okay? So let's see. If that's minus, this is going to be plus, right? And I have to look this up. So let's look this up. What is the molar heat of fusion of water? What is the molar heat of fusion of water? Molar heat of fusion of water. Let's see if we can find it real easily. 6.02 kilojoules per mole. The molar heat of fusion is 6.02 kilojoules per mole. 6.02 kilojoules per mole. Okay, so let's go back over here. And this is in joules, right? The first one's in joules, so I have to make this one in joules also. 6.02 times 10 to the 3 times equals 6.68 times 10 to the 6. 6.68 times 10 to the 6. 6.68 times 10 to the 6 joules, right? And this is the opposite direction. This is warming, right? This is putting heat into it, but this is getting heat out of it because we're freezing it, right? So it's going to be opposite. If this is minus, this is going to be plus. That's really important to appreciate. And let's go back to red for the last step. The last step is from 0 to minus 20, and we're getting heat out of it here also, right? And it's going to be NC delta T, which is going to be 110 or 1110 moles. But this is solid now, right? And so it's going to be 37.15 joules per mole Kelvin. Again, going back down to minus 20, right? No. Yeah, it's a change, right? Yeah, 20. So is equal to, I gotta do that in my calculator, 1110 times 37.15 times 20 is equal to 0.833 times 10 to the 6. I'm going to keep these all in the same regime, right? 0.833 times 10 to the 6 joules. I wanted to make all these 10 to the 6 because they're all, you see 10 to the 6, 10 to the 6, and 10 to the 6, so that way I can add them more easily. So this is, I can appreciate that this change in temperature, right? That's the thing that's going to make it negative or positive, right? Change in temperature, watch this, is T2 minus T1, and T2 was 0, minus T1 is minus 20. This is going to be positive then in that case, and this is going to be negative. And this is going to be negative because T2 here minus T1, that's this delta T, right? T2, the final T is minus 20 minus 0, which is going to be minus 20, right? So this is going to be minus, so this is also going to be minus. So yes, we got this right. So it looks like it's going to be 1.69 minus 6.68 minus 0.833 all times 10 to the 6 joules. All right, so let's get this 1.69 minus 6.68 minus 0.833 is equal to 5. It's really negative, right? 5.823. Negative 5.823. I'm going to go to a different color yet. And there's our answer. Minus 5.823 times 10 to the minus 6 joules. Let's go over to our snapshot. Make sure that's one of our options. I think I have that snapshot. Let's go to downloads. Let's see if that was one. And sure it was. There's our option right there. -5 point. That's it right there. It looks like the answer is B. How close were we with our estimates? I said 5.823. This is 5.81. 5.81, and that's it. It's B. Okay. All right. Hope that's helpful. I will stop this recording now and wish you the best.